You can calculate the contracted length of an object using a Lorentz transformation. This is a linear transformation that involves a rotation of space where velocity is constant. Deriving it into this formula shows the relationship between the speed and length, and it can be used to determine how much an object or displacement appears to be contracted. Let's break it up into its different components using the example of the rocket. Starting from the left, Lm represents the relativistic length, or the length observed by the astronaut on the moving frame of reference. In the example, this value is unknown, but it can be determined with the given information. Ls represents the proper length, or the length that is observed by the stationary frame of reference. Here, the observer on Earth is stationary, and the value measured is 384,400,000 meters. V is the velocity that the moving frame of reference is traveling at, so the spaceship is moving at 2.98 times 10 to the power of 8 meters per second. And c represents the speed of light, a constant that is always equal to 2.99 times 10 to the power of 8 meters per second. To solve for Lm, we rearrange the equation in terms of Lm. Then we plug in the variables provided, and we arrive at the answer of 31,412,272.5 meters. To conclude, length contraction is the phenomenon that the length or distance viewed from an object traveling near the speed of light is shorter than its actual length. It can be solved by using this formula, and it happens when a moving object in one frame of reference is observed in another that is traveling at a slower velocity. Length contraction happens in our daily lives whenever we observe an object moving, but the change in length is so small that it is negligible. It only starts to become relevant when the object is traveling for a very long period of time near the speed of light.
Created using Powtoon.